do we use this line? After we have drawn this curve, before flaw detection, we need to enter the thickness of the workpiece first. Click the focus button. There is an arrow. Then enter the space thickness. For example, let's detect a 20 thickness plate first. Enter 20. Now I rotate it. It changes by 10. You can also press this knob. It can change one by one. Set it to 20. There is a step distance. Just set it to 20. After setting it to 20, next we need to adjust the detection range. In the generation, the detection range needs to be adjusted. Generally, it should be about 4 to 5 times the thickness. It will look like this after welding. If it's burned, for example, this is a butt weld. Let's start with the simple one. First, stick the probe vertically in front of the weld. Then move backward. Push forward and move backward. Push forward in a zigzag pattern. When moving backward, you should move a certain distance. A certain distance. Generally, it is about 4 to 5 times the thickness of the bow. For a 20 thickness plate, you need to move more than 100. When scanning like this, you must apply coupling agent. While scanning, we observe the changes of waveforms on the screen. If all the waves are at the bottom, below this line, there is no problem. When there are waves exceeding, we need to analyze it. Look, there is a wave rising here. After finding this wave, this is a defect wave. We need to adjust the gate to the defect wave. Let's narrow it down. After adjusting it up, we check the positioning. First, look at the horizontal distance. The horizontal arrow shows 56.2. It's from the front of the probe. Measure 56.2 millimeters, which is exactly on the hammer. Then look at the other one. The downward arrow represents the depth. This is 56.2 millimeters forward. Vertical down 6.2 millimeters. This is a defect part. If the defect exceeds the top line, it is definitely unqualified. The higher the curve waveform is, the larger the curve is. If it's all below this line, then there is no problem. This is a weld inspection. The same principle applies to the inspection of corner welds. For example, this one is too big. Okay, let me show you this small one first. For example, this corner weld. Like yours. For example, for you, it's too big to move. This small one. For example, like this one. If the weld is left in this position, you can scan from the opposite side. From this surface. To scan it from this surface, and scan it back and forth. You can also use a straight probe, but the slope of the straight probe is not good. Then you can only use an oblique probe from this surface. Just put it on this surface. To scan back and forth, the wave will hit it diagonally and hit this surface, and then we can observe the waveform changes. If all the waves are below this line, there is no problem. If it exceeds it, it starts to be recorded as a defect. The higher the waveform, the bigger the defect. Well, that's it. You can practice first.